Assalamualaikum and hi, my name is Nur Ailin Shazmi binti Azhar. My matric number is 256780. I would like to present to you my research. My topic for research is application of discrete event simulation for queuing system improvement at post office counter. Introduction. All needs to have queuing experiences and it has been part of our lives. The servers will accommodate customers and on time if indeed the response were considered consistent. However, the risk of waiting is still quantitatively unfixable and the risk is impossible to estimate accurately. The approach like simulation may be used to help refine the existing queuing mechanism. The numbers of counters in post office should be optimized so the queue length of the customers would be reduced. For the problem statement, one of several key issues with the queuing method was indeed the discipline of the queue. A queue occurs when there are more customers than employees to serve them. This means that the customer have to wait for their turn. If the waiting times of queues are too long, the customer will get irritated and leave the system. Simulation is the replication of an actual mechanism or system operation to overcome this kind of problem. Research objectives were designated briefly what the research is trying to accomplish. There are three research objectives in this research. First, to identify the level of customer satisfaction of the postal services. Second, to develop the model of the waiting line process in the post office using Arena software. And the last one is to suggest possible ways to improve the queuing problem in the postal office. Research methodology. Since the study is to develop the model of the waiting line process in the postal office using Arena software, therefore, survey approach was considered appropriate to collect data using observation from the post office staff and customers who are using the postal service for the purpose. This is the flowchart for post office queuing system. This chart is easier for customer to understand the flow of the queue at the post office. The paper is meant to support customer by reminding them how long the expected waiting time will be based on how many counters in the operation. Model assumption. All above approach is designed with the following assumption in view, which is different service facilities since different kind of services are performed at each counters. A queue with unlimited waiting space that fits into counters. Customers are served on FIFO, which is first in first out basis. Arrival of customer were random and the time of service, though the time spent by the customer to complete the service is also random. The proposed model. In this analysis, the flow of customer to the post office is simulated and by measuring the time of each process is calculated and the number of customers who have accessed the facilities from each process is also determined. The process of simulation is finally underway. A summary of this type of analysis as seen in figure 2, a short summary of the facilities at each counter are as below. Counter 1 and Counter 2 for collect and pay bills, and for Counter 3, drop parcel only. This is the flowchart of the proposed model with phase of data collection. Identifying and collecting the input data that needed by model, such as time between arrival, processing time at each station and route, time between counters. The data used in the queuing model is collected for an arrival time of each customer in 3 days by observation for the number of customers in a queue in the post office of the arrival time and departure time were taken without distracting the staff. The whole procedure of the service unit each day was observed and recorded using a time watch during the same time period of each day. The next one is data collection. I have collected the data of the customer arrival time, inter-arrival time and service time for 3 days at the post office counter, which is starting from 29 December 2020, which is on Tuesday until Thursday 31 December 2020. The next one is fitting distribution. This is the service time distribution by the postal service, which is customer arrive. I use random expo 2 minutes, counter 1 negative 0.001 plus expo 1.58, counter 2 negative 0.001 plus expo 1.6, and counter 3 negative 0.001 plus gamma 6.3, standard deviation 0.3. The working hours was from 8:30 am to 5 pm, which is 8.5 hours or 510 minutes. The data analysis for each counter is carried out using a time study methodology. Throughout the subsequent, the analytical distribution of each counter was given by the input analyzer as seen here. Next one is run length and number of replication. Number of replication I run is 1, and the replication length is 510 minutes, which is equal to 8.5 hour or 8:30 am to 5 pm. For 24 hours per day, waste time units are in minutes, and the replication ended at time 510 minutes. For the verification and validation, formula of validated level is simulation output minus actual output divided by actual output time by 100%. The simulation output is 263 and the actual output is 200, and my validity level is 0.251%. Since the validity level of our model is in between plus minus 10%, we can conclude that our model is valid. Next is analysis and interpretation or phase of model analysis. The following performance measures of the system would be generated from the simulation model, such as WQ is average customer waiting time in the queue, W average time spent at the counter including the waiting time in queue, number in, which is the number of customers arrived per day, number out, which is the number of customers served per day, and LQ, average number of customers in the queue per time period. Based on the value of this measure, it can give the analysis of the performance of the post office service system. This is the sample of model that I had proposed in the Arana software. After running the simulation, and I already had the result, which is the average total production is 260. So we can conclude that counter 3 is the most busiest counter among the 3 counters provided, because we can see that there are 2 more at the counter 3 when the replication ended at 510 minutes or 5 pm. According to the finding, the customer has the longest waiting time on counter number 3 with an estimated duration of 2.6434 minutes. By then, the number of counters are in second place with a waiting time rate of 0.51130 minutes. Based on the result, the number 3 counter is not reliable. The greatest service level provision consequently did belong to just the number 2 counters. In order to solve this problem, one scenario is suggested. Next is model experimentation, which is I had put 2 intervention or suggested scenarios to overcome the delay of the post office service and to achieve satisfaction of the customer at the post office. For the scenario 1 is I had proposed to add another 1 counter, which is the total counter will be 4 counter, and for the scenario 2 is I had proposed to add another 2 counter, which is the total counter will be 5 counter. For both scenarios, we can see that there is comparison with the basic model. We can see that all waiting time in this study is dropped to 0, where that is exactly what we want in this study. The customer don't have to wait for too long in the queue at the post office counter. So when they arrive, they will directly go to the counter to proceed with their desired service. This can increase the satisfaction level of the customer at the post office counter. Since both of scenarios having the positive result, so we would like to choose which one is the best between scenario 1 and scenario 2. So here I had done two comparisons between both scenarios. We can see that even though the result of both scenarios is positive, but from the comparison we can see that scenario 2 is having the lowest number of waiting time and lowest utilization compared to scenario 1. We can say that scenario 2 is the best intervention to reduce the waiting time of the customer spend in the post office counter. For the recommendation, from the result, the suggested scenario of the best way to reduce waiting time in the post office is scenario 2, which is total number of counter is 5. This is because the maximum of waiting time in queue will be reduced and would directly increase the level of customer satisfaction towards the post office service. This result will be the effective way for the management in handling the long queue of customers in post office. In conclusion, this study has applied the discrete event simulation approach in modeling the queuing system at post office counter. Currently, there is only 3 counters at Post Malaysia Post Office Sanglun, Kedah. They are having problem of customer dissatisfaction towards the long queue at the post office counter. This study helped the management to finding the solution by developing simulation model that later could be used in carry out what-if analysis to reduce the waiting time in queue. Originally, there is 3 counter with 3 staff that operates from 8:30 a.m. to 5 p.m. daily. Based on the analysis, this study proposed a solution to add more counter at the selected post office. The counter added is 2 more counter to smooth the process of the posting matters and bill payments at the post office counter. This alternative will significantly reduce the waiting time in queue and improve the customer satisfaction level towards service provided by post office. That's all from me. Thank you.